3.3 is about solving equations with variables on both sides. We follow the same rules we have been doing in 3.1 and 3.2. I'm going to follow them in the same order that we were stressing in those lessons. So our first step, get constant terms together. The first thing I'm going to do is move my constant terms, and I'm just going to move it to the right first because that's the way we had been doing it earlier. Writing with my finger again. Alright, we have, this leaves 7n over on this side, and 10n, and then we have a positive 18. Same rules, practicing them again. Alright, now we need to get our variables together, so they're going to claim the left side of the equal sign. So I need to move this one from this side over to the opposite side. Balanced equations, same thing. Alright, 7n combined with the negative 10n will give you a negative 3n. And our constant terms were 18 when combined. Again, I want to solve for a single variable. So I need to divide by the coefficient. Negative divided by a negative gives me just the plain old 1n. I'll just write n. And 18 divided by a negative 3 gives me negative 6. Positive divided by a negative. Alright, I'm just going to go ahead and move that over. And I'm going to solve it this time, moving in the opposite direction. Let me see about this. I'll move my equation over here a little bit. And this time, if you're worried about having a negative coefficient, there's really no reason to, because you're going to divide by that negative and it's going to come out positive. But if we wanted to move things the opposite way, I'll go ahead and I'll do that. Alright, so instead of moving my constant terms to the right side, I'm going to move them to the left side. I'm still doing them first. Again, it doesn't matter what order, but I would try to stay with the same kind of routine to lessen your confusion. So now I end up with just plain 10n on this side. Over here I still have my variable of 7n. Negative 5 and negative 13 gives me a negative 18. Now I need to move my variable, because I said they were going to go on the right side this time. I can see in doing it that way, I end up with a positive coefficient and a negative constant term. But applying the rules of multiplication and division with positives and negatives, you're going to see it comes out exactly the same. And it's going to equal a negative 6. So moving on then, we have two special kinds of equations. Some that have no solution and some that have all numbers as their solution. Pretty tricky here how they put it in the book. I copied it the same way. The first step, because we have some parentheses in this equation, is that we need to simplify it. Parentheses mean we need to do the distributive property. See how good my finger can write this one? Not bad. And so 5 times 2x is going to be 10x plus 5 times 1 is going to be 5. And copying that to the right side equals 10x. Now I can stop right there because I have the same variable. Even with the coefficient I can see this. I have the same variable, 10x. So, can the same thing be equal to each other if one side we add 5, the other side we don't add anything? No. So right now I know that this cannot be solved. It's a no solution. Doing the same process on this other side, again we have some parentheses, so we need to do the distributive property. This side of the equation is already simplified, so I just copy that. And now I'm going to distribute 2 times 3x equals 6x. And plus 2 times 1 equals 2. Again, I'm going to stop 1 minute here. I have this same variable, 6x and 6x. And on either side of the equal sign, they're both having the same operation done to them, adding the same constant term, positive 2. So both sides are exactly right, so this are exactly the same. So that means no matter what I substitute in for 6, that all numbers will be the solution. And that's already the end of this lesson. Of some minor little details, the process in solving them is exactly the same as we did in the first part of the chapter. So I'm going to address lesson 3.4 and lesson 3.5. First of all, just an introduction or review of what inequalities are. Inequalities mean that we don't have an exact answer. We have that it's all the answers that are compared to it. So if you look at this first sentence, x is less than 3, I would go ahead and I would find 3 on the number line. And I'm going to mark 3 with an open circle because it can't be 3. And I'm going to then shade to the left, okay, just by making an arrow pointed to the left. The next one, y is greater than 2. Again, same thing. I'm going to find that answer on the number line, put an open circle at 2, and this time it's all the numbers that are greater than 2. The next two are less than or equal to and greater than or equal to. So it says z is less than or equal to 4. I'm going to find 4 on the number line, but this time I'm going to give it a solid dot because it can actually equal 4. Z can equal 4. But then it is also all the numbers that are less than 4. And so that leaves us with our last one, n is greater than or equal to 2. Solid circle or dot and shaded to the right. Now you'll notice in each of these statements that they gave us for the first example, the variable comes first. When the variable comes first, you have one more extra little hint on how to shade. The variable symbol will point to the side, the way that the number line should be shaded. So the only thing you need to worry about is an open or a solid dot. This time it says writing and graphing an inequality. So our variable, it says, is going to be T. Let T represent the temperature of water. And water is solid at temperatures less than, so T, temperature of the water, when it is less than or equal to 0. There's our inequality. When you're drawing number lines for me, I just need you to have the number that is your solution. I would like to see that you know from the positive to the negative, so some labeling for positive and negative. This isn't the best example since the answer is actually going to be marked at 0. And again, we're going to do a solid because it says equal. And whoa, shade to the left. Mine got a little carried away. The next thing we're going to do is look at the adding and subtracting properties of inequalities. The reason we're only focusing on these two properties is because in both of these sentences we have a single variable already. So we're just solving for that variable. Same rules apply that did when we were doing equalities. Get your like terms together. So using balanced equation, make sure you put your equal sign there, leaving us with just m on this side. These canceled out. And get your inequality symbol, and 10 minus 5 is 5, or 10 10 combined with a negative 5. Again, if I was going to draw a number line, I'll just do a sloppy one here. And I would put my 0. My answer is 5, so I'm going to mark 5 on there. And I might mark the mirror image of negative 5 on the other side. I'm going to make it a solid dot because it has an equal sign, so it includes that number. And then the inequality tells me to go this way, and if I think about it, m is going to be any number that is equal or greater than 5, so it would go that way. Same thing here, however, the variable's over on the right side of the inequality. So same first rule, constant terms together using balanced equation. I'm adding 12 to both, equal sign showing that I'm calculating there. Leaves me with x here, and a negative 10 combined with a positive 12 would give me 2. Now in this case, my variable isn't written first, so I'm going to rewrite it so that it will be easier for me to graph. When you're rewriting it, you want to make sure, and this wasn't a very clear inequality symbol, you want to make sure that you do not change the inequality. So in this sentence, the inequality is pointing at the x. I want to do that again. And then I would read that as x is less than 2. Now when I go to graph this one, I can again put my 0 so I know which side is negative, which side is positive. My answer is 2. I can put a negative 2 over here as well. And this time it's going to be an open circle, and it's going to be shaded to the left. So nothing new in that lesson, it's just in inequalities. However, in 3.5, we're going to talk about multiplication and division because we are not going to have a single variable. Again, the same process with one difference. If we are multiplying by a negative or dividing by a negative, you need to make sure that you reverse the inequality sign. Now you might want to pause this and write these notes down. Otherwise, they're also the questions that I ask on the form. So let's go ahead and try one. The first one we're going to do is going to have to do with a fraction. So m, our variable, is being divided by negative 3. In order to change that, we're going to multiply both sides, balanced equation, by a negative 3. Because I'm multiplying by a negative, my negative 3 would equal 1, so I ended up with a single variable. However, I need to make sure I reverse the sign. So m is actually less than a negative 9. Moving on then, I have this time a variable that is multiplied. It has a coefficient. Negative 10t is greater than or equal to 34. So to get it as a single variable, I need to divide by negative 10 because negative 10 over negative 10 would give me t. And if I do it on that side, I need to do it on this side. So 34 divided by a negative 10 would give me 3.4. And I divided by a negative, so I need to remember to reverse my sign. Again, same kind of graphing rules that I was using just a little bit ago with 3.4. And that finishes that lesson for me.